Cool. Okay. Oh, I shouldn't have this open. No. Okay. So where to start? Okay. So today I have Paul and Gregor with me, and we're gonna do some lean metaprogramming. So we're gonna add one dependency, and this is like the Ltac file. So you need to add this quote for dependency if you also want to play with this. But let me start at the start. So in Coq, we had all these proofs about lists and hint databases, and we had other proofs about lists, and then we had like this metaprogramming things that kind of looks at your goal and then applies tactics. So it sees, okay, in the goal you have some x concatenated with a y cons some y's, and then you just want to apply this theorem that basically says exactly this, right? But you can be quite elaborate on all these things. You're like pattern matching on your hypothesis and goal and applying tactics as you see fit. And you're rather programming this than doing it yourself. So the idea is that if we see some list formula in our goal or hypothesis, then we can just apply this tactic and it will do the thinking for us, because we're way too lazy to prove everything about lists. Especially after we've proven it once. We don't want to think about it again. So we want to do this type of pattern matching in our hypothesis and goal, and then tell Lean, not Coq. This is just what we've done in Coq before. We want to tell Lean what to do, like apply this tactic or destruct or split this goal, and try to rewrite things. Now,
yeah.
So we've
done make one point about about being lazy. Yes, it's about being lazy, but also I think it really opens up like a different level of exploration. So you can just explore the hypotheses and so on, which I found in Coq anyway, that you can just start exploring in a way that you wouldn't do if you had to actually think about what to apply and so on. Yeah, so it like opens up more possibilities.
I think it also opens up some of your brain capacity, because it's just like,
yeah, exactly. That's what yeah.
When you prove things about regular expressions, you get so many lists or strings, and you're just like, oh, this is so obvious, but I can't remember how to prove this. I can't remember what the theorem is. I just don't like, again, come on, like, I just don't want to see this. Just apply this tactic that knows how to deal with lists, and then I can continue with my life. We've put in all this effort in Coq because it was so frustrating to deal with. So it was totally worth the effort. So like, now that we're doing it in Lean, I want to try to do it in Lean again. All right, now for this, like I mentioned, you just need to add this QQ dependency, because it's going to be really useful for the pattern matching and creating expressions. Yeah, so I've done a little prep work. Okay, here, so just some references to help me, so we can ignore that. We do need to import QQ and open up a bunch of context here, just so that we don't have to qualify everything. Like I do prefer to qualify everything, but while we are learning, let's ignore that for now. But later I would like to not use open and just qualify. I prefer qualifying things. But so let's say we have this theorem, right, that an empty list is not equal to some list concatenated with an element in the middle and concatenate with a sum list, because even if these two lists are empty, we at least have one element, so it can't be equal. Now, so here's our metaprogramming going on, and it's involved, right? But we're just, don't worry about it too much, okay? Because a lot of this we can ignore, and we can really focus in on the parts of the syntax here that is important. This tactic, all it's going to do is going to look for if the goal is this, right? And if it is this, it's going to apply the theorem. So very, very stupid tactic, but you already don't have to remember the name of the theorem, for example. It's already weirdly useful. So the first thing we do is we get the goal, like what is the goal? And then this line, just ignore it. It's just getting the type of the goal, okay? And that's what this tie is. So this should be like goal type, might be better, right? And now we're using the Q library, the QQ library, to do pattern matching on the goal, on the type. So that's what this means. And then we can write out our goal. And here, when we put a dollar in front of a variable, then that says like that's a pattern. Like we don't really know what's going on there, but like that's some variable, and we don't care what it is. And
so is it just that XS has the like type list, or can have like any kind of strange form?
I think this can be anything, but like it has to be a list for. If you use type inference, this will have to be a list, right? Like, but technically, this is not a list; it's an element.
Yes.
Yeah. But yeah, obviously the type system still makes constraints here, but I don't know if it's exposed at this level. I don't know if we'll get a type error, but yeah, I'm still pretty new to all of this. So all we need, but we can also like simplify it, like I'm trying to simplify it in my brain. We're just getting the goal, we're getting the type of the goal, and we're doing a pattern match on the goal. And then we can run a tactic. And we're just, this is the part of the tactic we run. So we're just applying that theorem, right? And again, so this is just syntax, If you want to not think about it, you can, right? Yeah. And if we have here, we have like an example theorem. In case we don't need this, I guess. Doesn't matter. But when you say apply it, it solves all the goals.
Yeah.
Because there's just one. And here's just a way to print out what we want. We can just log info, and we can use string interpolation to extract those variables and actually print them out, which is pretty cool for debugging, because while doing metaprogramming, debugging is quite useful. And yeah, so that's what I got so far. Yeah, so I think what we want to do is also, this one is different. It just prints all the hypotheses. So there's some syntax to get all the local declarations. And then this for loop just for loops through them, right? So, oh my God, imperative programming. Oh no. But it's fine. We'll all survive. And it just checks the type again with the same check type Q syntax. And then we can do pattern matching on those hypotheses to see if there's something that we want. And I think we can get the name as well. Let's see. Late name. Yeah. And then let's see, name. Yeah, and then if we say print, yeah, then it says the hypothesis that matched is H1. So we're gonna need this name if we want to apply things. I still don't know everything we need. For example, I don't know how to create a fresh variable name, which we can skip for now and just make up unique names ourselves, but later we'll need to figure that out. And then yeah, how to apply this hypothesis, like can I just put the name in here, or do I need some special syntax because it's quoted? So it's going to be interesting.
Yeah.
Okay, do you two understand everything here so far? Then, yeah, maybe you have a question. Or
Well, everything would be a bit of a stretch, but that makes sense at an abstract level, I think.
Yeah, I'm not asking you to understand this because I don't. But yeah, do you understand the idea of matching this expression? And then if we match it, we apply a tactic.
Yeah, I understand the idea, but how do we refer to the actual match then?
Yeah.
I don't see that.
So here, in this side, we're applying it to the goal, so we don't need to refer to it. But if in one of the first things we're going to do now, we're going to need to figure out how to refer to like this hypothesis name. And yeah, I don't know how to do that yet. We're going to figure it out. So that,
Okay.
yeah, your question will be answered or not answered very soon.
Okay.
But it's the right question. It's the perfect question. That's all I can say.
That's the same question you had, basically.
Yes.
So and the pattern matching, is that triggered by the tilde q?
I think yeah, I think this tilde q is used to, yeah, I think it does two things. I think it creates the expression, but it also creates the expression with these holes. And then does the pattern matching out of this type. Yeah. Well, okay, so I guess it just does the pattern matching, actually. Yeah, I think that's a better way to think about it. Yeah. So you were right. It took me a while to get there.
Oh, and is it then that like the whole let expression has like a true or false return value? So if this assignment of the pattern matching to ty is successful, then we continue.
Yeah. So this is like lean imperative programming here, right? Because in functional programming, you expect your if else to return.
Yes.
And this is just doing imperative programming right here. Like it's just, oh, if it doesn't work, then go to the next line, I guess. But there is no next line. So I'm kind of wondering if we do, yeah, let's say x equals x, right? Yeah. Yeah, here. There we go. So you can just sequence them, all your pattern matches.
Okay. Yeah, and the fact that like the let expression itself can have a Boolean value, that is also new to me. I mean, if I understand it correctly, you could put brackets around the let expression, right? Because it's between the if and the then. So that so before let and after ty.
If let is the construction here.
Yeah.
Oh.
If let is like a I don't know though.
Yeah.
Oh, okay. Then I was. That's interesting. So if let is something completely different to if.
Yeah. So it's inside a do block.
You
can have the if let to destructure. So it's like in Haskell where you can you can bind with a pattern.
Well, yeah, but it's saying only if this binds correctly. So it's basically it's doing a match, saying if it binds, then set it equal to, well, yeah, set it equal to ty.
Yeah.
And execute this code. Otherwise, nothing. And then also the imperative part.
Yeah.
Okay. I think it makes more sense now.
Yeah, I'm also struggling with it. Just to be I am struggling with it. Just to be clear, but so I put in another print just to. I want to check something. Yeah. So this might help. Okay. Here we are matching with name one, right? But then we're also matching name two. So it executes both for each. It's not like shorts. It's not an if else, right? It's if. So it's really imperative, not functional here. Also weird that this is matching because I'm saying these two sides have to be equivalent, right? They both have to be x, but it matches the hypothesis one.
But so it's the for do that puts us into imperative mode, isn't it? Oh, we have a do before, I see.
Yeah, we have a do before, yeah. But Paul, are you also with me here? Like, do you see this name one, name two, right?
Yeah.
You
see that like x's plus y's colon y's, like this equal to the empty list matched x equals x.
Yeah, so maybe it's just matching. It's just matching the shape. It's just matching the type, and actually there's a shadowing here.
Yeah.
So it's binding x and then binding x again, but it's not checking the values. It's just checking the type.
Yeah, which is we have to keep note of, because like in Coq, it would make sure that the two are equal.
Yeah, it's a bit weird that you're allowed to shadow.
Yeah,
if that's the case.
So we would need to do this.
Should like not shadow? Yeah,
and
we shouldn't shadow in those things.
Oh, I think there's a in the metaprogramming book. Over here. You can ask if two types are equal.
Ah.
So in their like simplified or normal form, equal or
Yeah, we hope. Okay. Yeah, does this work? Yeah, that works. So we just need to do this manually. You see that the printouts here? I just want to be sure.
Yeah.
To make sense, Gregor?
Yes.
All right.
Yeah.
Cool. Okay, so we had some issues with matching, but now we have better matching. On our hypothesis. Now we still need to figure out how to apply something, right? So what I'm thinking, let's make like a really stupid thing where we say P is A goes to B and Q is B. No, Q is A. Oh, A is A. How about that? And we need to prove B, right? So very stupid. Okay, that, I mean.
Modus ponens.
Sorry?
Modus ponens.
Yeah, they're very stupid. So, okay, so let's make like a stupid tactic that can prove this for us. Just to see we can pattern match and then apply that hypothesis.
Yeah.
Okay, so we want to match X to Y. Did I? What's wrong?
Total Q.
Yeah, it can do this. That's
Yeah.
not. Okay, let's just see. Maybe there. This is a library where it's being used a lot, so I'm just using it as a place to get some examples.
Doesn't see like not equals. Oh, there's if and only if there. That's
Which
it's like a not online 57. There's an arrow there, but it has a not in front of it.
I see. Maybe it helps if we say A is a prop.
Maybe you say dollar prop.
What would a dollar before a type mean?
Oh, sorry, no, I didn't mean dollar prop. I meant $A colon prop.
Mm.
Or we can maybe add another paren.
Hmm.
Oh, let's just rename this.
But in our examples, A and B are not even props, right? So.
Oh yeah, we didn't even say this, but we can do. It's yeah, it'll be fine. Here's one. I think this is it.
Right. Lots of type annotations there. Okay.
There we go. Okay. I think it must just be hard because of the arrow. Okay, but so we have the name. We can even say let's say it and see. Sorry. Yeah,
P,
so
X's, Y's, yes.
it works. Okay, A, B. And now we just need to apply it. So let's try this. And I think I'm gonna guess. Unknown identifier name. Oh, that's not good.
Yeah, because it needs to be unquoted. You put a tilde in front of it. You know, you unquote stuff. This library.
Yeah, let's see. Maybe they have more examples here.
Yeah.
You.
So they say, where is this H bound to? That's like on line 46. Because they say H2 expression to expra. So what is H bound? On the right hand side of that colon equals. So H is that the L decal in our example? So maybe we on our L decal is the thing.
Yeah, but
Let's say L decal to expra.
yeah, but we just want to apply the name, right? Or okay. Right. We need this name.
Yeah.
Yeah, I don't think that will do string. Yeah, that's not gonna work. I'm just gonna comment this out because it's kind of irritating. Yeah. So what is doing is quoting it, and then it can reference that.
Yeah.
I don't know if you can do this.
Isn't the backtick there also quote?
Sorry.
On line 47, you have the backtick before tactic.
Yeah.
Isn't that a quote? Or what is?
Yeah.
Is that equivalent to Q? Or maybe use Q here and then. Yeah, don't know. Yes.
What does quoting mean?
Yeah. That's a really good question. How do I? Paul, do you want to take a stab?
Yeah. So
I'm so struggling. I
yeah,
knew,
so
I knew it and I forgot, and now I'm trying to play catch up as well.
so here we're not so on this line 47, what we're not doing is calling apply with name. What we want to do, we want to create some syntax. We want to write some syntax. So we have this name which we've got from somewhere as like a string. And what we're trying to do is construct the string, apply, and then the name of the thing we want to apply. And then what we can do is we can use quotation to actually introduce that into the program as some syntax, and then evaluate it.
Oh, so
this is the meta part of metaprogramming. Like we're yeah.
So name is replaced with whatever the string is, and apply says apply, and then we have the string apply, name replaced, and then the whole thing is evaluated.
Yeah, so we evaluate it as if it was like we're introducing the syntax into the program at this point. We're like doing like code generation.
Okay. But
then we have this special thing called eval, which then takes that syntactical construct and then evaluates it as a Lean expression.
Okay. So, but apply stays apply and name is replaced, or
well, that's the problem.
Well, that's what we're trying to do now. We don't know how to inject this name that we've got into this syntax. Syntactical expression.
Okay, I see.
Yeah,
I think now we're on the same page.
Yeah, we need to basically know how to interpolate here.
Yeah,
this B was done, right? So we just want to know what's the syntax to interpolate this name here. Instead of literally saying name, we want to say name's value.
So what about using the round, the braces, the curly braces?
Yeah, I think they just work for strings. Yeah.
So what is the name? Sorry, what is the name of the library? This quotation library? I can dig around in
QQ.
QQ.
So it's Gebner quote 4.
Quote 4.
So they have some examples here. This is one that just prints. So we can see they have ones to convert. So Q can also be used to like create an expression. Okay, that's the one we looked at first. Yeah, this is also creating an expression.
So what if we?
This is interesting.
Yeah, what if we? Yeah, I suppose the bit I don't know about is the backtick in the tactic thing. But what if we just want to create? Because that backtick is part of. Well, I'm assuming the backtick is part of Lean syntax. So therefore, the Q should go around the whole thing. The Q should wrap the whole thing, including the backtick. And then the dollar, we can then use dollar inside of there, dollar name. But yeah, this doesn't work. So backtick is something, but like the syntax is difficult to search for. It's like these operators are just so annoying.
Yes.
Yes, they don't have names. They're easy to type, but then how do you search for it? Or how do we even type backtick on my keyboard?
I wonder.
It already looks like there's some little quotation happening. But
like even this is like a no-no.
What's it?
Yeah, okay. This
What's
is the
the
problem
error?
with just this is the problem with just importing everything.
It's not unquoted. It's not unquoted that dollar name on line 47.
Yeah,
Which is what I
also
was expecting it to do.
it's also not quoting the apply. Like I would hope it to do. It's trying to call the function apply. So close.
Mm-hmm.
In clause convert prop.lean, they use dollar signs in this queue, in this quote thing.
Where?
So I'm in the quote for examples close convert prop.lean. And they're in line 15, for example, they do some pattern matching, PPS, and then they have Q, and inside the brackets they have dollar signs.
Yeah, yeah.
So maybe that is how they refer to
Yes.
that.
Yes, exactly. But this is inside a queue, right? Unquote with dollar. So this is perfect.
Yeah.
Except we're also inside tactic. So we need to figure
Yeah,
out.
so this is some magical I don't know
Unquote.
what the hell this is, syntax.
Yes.
How do we search for what this is?
So this is explained in the metaprogramming book.
Oh, okay.
I think.
Because can we just not use that syntax, and is there like something that it expands to, which makes more sense?
So there is. So what happens is, oh, come on.
There's a backtick.
No.
Well, what is it?
If you create some syntax, you create a syntax kind of namespace.
Right.
I don't know if that's the right word, but and then you can instantiate things in this namespace. Yeah. So this is like a way to create a tactic in a tactic syntax.
So yeah, we probably cut. This is probably outside of what you can quote. So you probably have to like expand whatever that thing is. Like what yeah. So what does backs? If it's syntax, then we should but where is the syntax? So in that example there, arith, where is it defined what the syntax means? It's declared the syntax, but what?
Here's declaring the syntax. Here is the denotation of it.
Yeah.
And then
denote arith.
Expression.
Then where is denote arith defined?
Here.
Oh, right, I see.
So you create the arithmetic expression and then you can evaluate it.
But we're in this elab monad.
yeah, elaboration. So we just need to figure out, okay, given the syntax, how do you add a little variable here, right?
Yeah.
It might be somewhere here. Okay, maybe in the next chapter. It looks like dollar again, but let me just try dollar again, just check the error.
Oh, it's not
Oh, okay.
syntax. So we maybe 2 something. 2 expra or I don't know.
Oh, maybe let's see if we just search for this in MATLAB. Just
Okay,
almost.
but that's at least promising.
Yeah,
It's doing something. It's just that we got the wrong type of thing.
Yeah. Oh. I'm just baiting that people use Ltac. Okay, I'm gonna tickle that username. Okay, how about actually, where is this? Ah, great. Local data.
There's .2 expra, and that might make it into something that we can quote. What's it saying now? Let's type expra. Spectrum T syntax. Oh,
Sorry.
more stuff. So there's Merc app M, which constructs something in the meta M.
Hey. Yes.
Ident. Okay.
Oh, Okay. So
Hmm.
we were right about the dollar being the escape.
Yeah.
Okay, but what does make ident do?
It makes an identifier.
Oh.
Yeah.
Okay.
Yeah. Again, like, yeah, I want to stress here, like once you just know the magic incantations, you can really forget a lot of it and just go like, okay, this is the pattern I want to match, this is the tactic I want to apply. There's like
Copy paste.
there's one more or two more we need, two more magic incantations we need. But we can probably get quite far today just with what we have now. So I think I would like to see how much we can do with what we have and figure those out later. How does that sound?
That's encouraging.
Okay, so we can apply a tactic to a goal that fits our pattern, and we can apply a hypothesis to our goal given some pattern.
Mm-hmm.
If we look at Listerine, I think these are easy, like discriminate would do this for us, but I think since we're starting to learn, maybe let's try to match these and then just apply the tactic discriminate. And yeah. And yeah, we do need a new tactic name because we can't use Listerine again. So, but we need something with the word list in the name. But for now, we'll start with list empty, which will be a small part of this tactic. Yeah. So we'll just move this here. This is just our example code. Okay. So first we want to just match this hypothesis. We get all our hypotheses. We don't think about what that says. And then we can just do our first match. And what we want our match to be is equal to some empty list. We can roll this is something cons something else.
Yeah.
And if we have that thing, we just want to say evaluate the tactic, discriminate. No? Unknown tactic. Okay. Really?
Oh, but don't we have an arrow to false or something? No, there's not this problem, but there's this arrow to false.
Yeah. Oh, I'm just saying.
You want to apply discriminate.
This implies false. Yeah.
Yeah.
So, but if we have something x equals, if we have this as an hypothesis, then we could prove false.
Yes.
So we just say, is it intro? Right? That, oh, we don't need to intro. So we just need discriminate, but that's not a tactic.
Was it contradiction instead?
Maybe it's contradiction. Yeah. All right, that works. Contradiction. And now we can test it, which by exactly this theorem. Yeah, Sorry. Cool, that works. And now we can start applying more of these. So if it's the other way, we also want contradiction. If, okay, this is just cons versus using colons. I think will probably be okay. This is the one we just had, where this was in the goal. No? Oh, yeah, we also want, yeah, if this is in the goal, we want to be able to prove in the hypotheses, right? Sorry. Oh, come on. Then we want to somehow apply this to that hypothesis so we can gate false.
Right.
Yeah. So this is where, like, we need our third trick, but I think we can get away. Like, technically we need to know how to create fresh variables, but I think we can still get away without it, because we'll need to write something like have okay, like that's not, yeah, Copilot is not just but yeah, we need to write something like this with x's, y's, right? Well, no, sorry, we need to apply this. Given our Decal name, our hypothesis name. Oh, sorry.
There is a make fresh expra envar.
Oh, really?
Yeah.
Fresh.
You have to give it a type expra envar. You give it you give it a type, so it needs to be a type as an expression. So I don't know why I should paste this, but there's an example in the MetaProgramming book.
Okay, what about make fresh ID?
Yeah, it gives you a name, which is which is good enough, right?
Yes, yes.
We don't care about type, so
let's hope that's.
Oh, you have to bind it. So imagine that is the back arrow.
Yeah.
Oh, I don't know how you write that though.
Yeah, fair. Yeah, that's it. Cool. Okay, yeah, so we want something like this. And then we want to say contradiction.
Yeah.
So we have, can we write this?
Well, you need to make it an ident as well, I guess. You got your name, and then you need to call Merc ident. But after you've bound it, it's like
yeah, not always, but okay. Clearly in this.
Oh, okay. Well, it's in the monad. So.
I think you can do. Lean is like.
Ah, nice.
Oh no. Oh, maybe. Wait. Yeah, there we go. Lean really allows you to do that arrow anywhere. Where like Haskell's pretty strict. Like, I don't know, if I'm a fan or not, but like, yeah, it's pretty useful in this case. Yeah, so we want to write this. We can test it. Oh, yeah. Wonder, can we? No, you can't give an example and name. Okay. And I want to say equal and list empty. No, didn't see it. It's printed out. Just empty name. New name. Oh, okay.
What's it complaining about?
It didn't.
Does it say it's not unsolved?
It's not printing it out, right?
Yeah.
So it's not matched.
That did not match.
Yeah. Let me.
How much does the bracketing matter? Because, I mean, I suppose the concatenation, the double colon has a stronger binding than the double plus, but.
Ooh. Yeah.
So try to apply it. Yeah. Tried to apply it and failed.
Yeah, it didn't print out my. Oh, there it is. Yeah. So we're matching.
So then it's yeah.
So that was
Was it the bracket?
Okay, we can double check, but
no, it's still printing.
Okay, but I believe in the brackets. I want to add them back. Okay. Let's see the new name. See if that also works. Okay.
Yeah.
I don't know if that works, but yeah. What would be useful here is I just want to have one to print hypotheses for debugging purposes. And we can see if we added our hypothesis or not. Yeah, this will, okay. That was perfect, GitHub Copilot. That was just beautiful. Okay. And then we put it here. Can I? Okay, I guess I have to eval it, but that's fine. Probably a better way to do this. Weird. Oh, okay. Maybe already there. It's printed out here. Okay. Okay. There's printing out. Sorry.
Name.
Let's see. It says. Okay, there's printing out an hypothesis, another one. Okay, that's good. We're not getting here because it's not printing out the hypotheses. Okay. Okay, yeah, the apply is not working, or yeah,
This one, have new name.
maybe. Yeah, that does it. I mean, I see we finished, but I don't see our new hypothesis being printed, which is kind of, but I guess it works.
Why didn't it print? Odd.
I guess it's fine. For now, right? Later we do one.
Yeah.
For today, this is a one.
Yeah.
We even have a fresh variable, so that's like there's just one trick left, and I don't know what it is. I can't remember, but I know there's still one thing missing here. But we have 3 out of the 4 tricks we need to do. Most of the work we want to do. Okay, we've done that. Oh, we can also add our. Is it this one? No. Yeah, our apply it. Yeah. We don't just want to look at the hypothesis, we also want to apply some things to the goal.
Yeah.
So this will do that. Yeah. I wouldn't say this is as readable as this, but
well,
they're both not very readable.
Yeah. I suppose it's the argument for the other one, the lean one, is at least it's lean syntax, where the Ltac is just Ltac. Yeah. Well, but on the other hand, you've got this quotation business.
Yeah,
which is
Yeah, but let me. At least add the comments here as well. Oh, the power went out. Oh,
oh dear.
Like now it looks more readable, right?
Right.
And this one. This, yeah. Okay. Let's continue. Are you, yeah, your computer battery is still good?
Yeah, I mean, it's only when it's full, it's at 84%, but that should be enough.
Okay.
Yeah, it's got really bad recently here
Yeah,
with the amount of load shedding.
I heard it's now. Yeah, my wife is there, and she's like, oh, people are like happy about it only being stage 3 most of the time.
Yo.
We were like, oh wow, it's just stage 3. That's amazing.
Well, yesterday, no, the day before, it was stage 3. And when the power was supposed to go on, they switched to stage 5, and then there were immediately another 2.5 hours of load shedding just after 2 hours of load shedding.
Whoa.
Yeah, that's life.
That's crazy. Yeah, I think when I was there, like stage 2 was considered bad. Like that was.
Yeah, that's when I moved here. Was like that. Yeah.
Now stage 3 is the good state.
Yes.
It's amazing what 6 years can do. Like, oh, on to positive things. Okay, here's one, right? If we concatenate 2 lists and they're both empty, oh, they add up to an empty list, that means they both must be empty. All right, so we want to show this. Yeah, so if this is an hypothesis, right, that x's plus y's equals the empty list, that's when we want to be here. How do I? Okay, good syntax stuff. Okay, good. And then we want our test. No. Yeah, so we just wanted to split it up. And then one of the assumptions should be that y is equals the empty list. So we should just be able to say assumption. Then, yeah, then we know this is working. How do we do this in Coq? We applied one of our theorems. I think we have this here. No, or we decided to call it something else. Here we go. Yeah, can I just import it? lists. Let's see. How do we import things again? Yeah. Nope, we're not that lucky.
What? Why can't?
I mean, maybe it's just because I haven't added this to the project yet.
It's also still.
And some things aren't compiling. But so for today, don't worry. Like I'm just gonna copy this in.
Yeah.
I don't want to abstract. I want the. I want to obstruct the stream because of this. Okay. But we want to apply this in name, right? But we can't do that in Lean. We have to use have, so we have to give it a name. Maybe we can call this something like type name. And then, well, yeah, basically this. Wow, that was good. I wonder if that's the right amount of, yeah, that's the right amount of parameters. Holy shit. Wow. I mean, it's kind of obvious, but no. That's great. Okay. Sometimes it just amazes you. I mean, other times it's just incredibly stupid. Okay, this was amazing. Okay, it applies it. It creates our new hypothesis. Well, yeah. But let's see. We should be able to already see. No. Assumption failed. Yeah, I know assumption failed. I don't want to. It's like this hypothesis doesn't like.
What are you trying to do? Oh, you're just trying to add the hypothesis.
Yes.
Yeah.
And it's like the same thing that happened last time. Well, it didn't print it out because it's kind of like there but not there. You can use it, but you can't see it. So I'm thinking this. Yeah, make fresh ideas not doing exactly what we want. But okay. Let's see. Yeah, I want to do how did it know that? But no, that's not you can't do that. Okay. Yeah, okay, we do need this. Right. Like if this is H1. It also doesn't appear here. Okay, well, this might explain it. Function unexpected.
Very difficult to see what
the error is.
Oh, the function expected at term has type blah blah blah. 114. Function expected at. The list at nil nil. Is it saying that it's not a function?
But also it goes the other way. But let's just see if we do this. Okay. And what if just want to see if this is the problem? Yeah. Okay. So is the fact that it is an if only if.
Okay, so it's not a function.
Yes. It's like
fair enough.
I hate this. Like in Coq, it would just like go, don't worry, I got it. Like I'll figure out. I can figure out which way this goes. That's not so hard. Okay, but if it's I feel like I'm allowed to decompose this somehow, right?
MPR. Yeah, so can you just use dot? You tried that, right? Dot MP.
Yeah.
And then try to call it as a function. But then what does it complain? Oh, invalid field. So it's invalid field notation.
Isn't it like if dot MP at the front and then?
Yeah, maybe because it's not a. Yeah, I think that's right. What's it complaining about now?
Yeah, let's go again. Yeah, this.
Yeah, so you can see on line 668. Oh yeah. 668 has got this version. But without the parens.
Yeah, in one case you can just call .mp. The other case you can do this. I'm happy to do either. It seems
yeah, the first one it was saying it wasn't allowed because of blah blah blah, not a constructor of the type blah blah blah. So yeah, maybe.
Yeah, what's the
Now it's saying something else. Type mismatch has type.
Oh,
It looks. Oh, wait, yeah, if and only if expected to have type.
Oh, my. Okay.
Okay.
No.
All right.
So pedantic. Okay.
Maybe MPs, yeah.
Yeah.
Okay. So I was complaining that you were calling the method on like some for all type.
Yeah. So it should be this .mp. And we can see it.
Yay!
Now,
Yay.
let's try it with hype name.
Nice.
And then we won't see it, but. Oh,
Yeah.
it's there. Okay. That's great. Now, I think it's cases unique.11954. Or
Cases.
or apply and intro maybe actually. Oh, but you can't apply in. Where's that other file we just had?
Isn't it like and.left or something?
Oh yeah, we were here. Oh, were we here? It was 668 or something. Here, right? I feel like this was like one of the first chapters in the Lean book is how to split an and. Maybe it's
Yeah,
also...
it's and.left and and.right. Or
yeah,
you
but
can.
I want both.
Oh,
I want two new hypotheses. I want to go. I want to do this and then it be a thing. But yeah.
yeah, I remember we were struggling a couple of sessions ago. We were struggling with exactly this thing.
Yeah. So let's see.
Yeah, it's case right and case left, I think.
No, yeah, we should have both. That works for ors, right? Oh, here we go. H.left.
Ah.
So we say exact well,
whatever it's called. Oh, but you can't refer to it or something.
Yeah. But I might be able. Okay, let's make this H for now, right? H1.
Yeah.
And we should be able to say rename I think to H1. Yeah. Okay. And now we can say exact H1.right. And yeah, okay.
So what is rename underscore I? Rename intro? Rename...
Yeah, rename the previous one. And
right.
I think you can give a number here as well, but
right.
so we could.
Yeah.
Would this work? No.
Oh.
It's skipping because this has a proper name, right? All right. We'll come back to using hype name, but let's. So what we can do now to split it into two is to do two halves. Where. Right.
Yeah.
So now we can go left name, right name. Yeah, we do need to figure out how to do this properly. Then we go. Yeah, h1.left is HL, sorry. And then, yeah, and we should be able to say assumption. Yeah. So technically this passes the test. I do wonder if we can now do this. No. Okay.
You put the dollar sign so that maybe you need to put parens around hype name.left. No.
Yeah, that works.
Yeah.
And then we should be able to say left name, right name. Yeah, and that still works.
Okay.
So I still think we do need to figure out a better way because like we can't at the moment we can't refer to these names, right?
Yeah, I wonder why.
Like
probably for a good reason, right?
no, I don't.
Those things are not going to be stable. I would. That thing is not going to be stable at all.
Oh yeah, that's true.
Probably want to highly discourage you being able to change those, being able to refer to those.
I see.
Because people will depend on those things. And they complain when it doesn't work anymore.
Okay. How about if we say hype name is H, right?
Mm-hmm.
What happens here? Yeah, we get another H.
Yeah.
I think maybe this is better because
yeah,
now we can still rename it.
Mm-hmm.
And like it doesn't have issue with duplicates.
Yeah.
I think even if we say this is also H.
Yeah.
Hmm.
So many H's.
Yeah, okay, that's not ideal, but yeah, that oh yeah, because now it can't do left on the correct one, so it's kind of confused. But if this was H1, it would work. Yeah. Yeah, still has to be unique. So if you
But the uniqueness is scoped to
if you
if
you introduce one, it's fine. If it Oh, yeah, it's not ideal. Because like here, I need to know that this is not used yet. Otherwise, it doesn't work.
Wouldn't it automatically rename it? We could try. We could
Also,
try.
the problem
We
is
could
this name
Mhm.
is now the same as this name. So when we say apply, it's like, whoa, I guess it's that one. But it,
Oh, yes, I see.
this is the problem. But we could say, yeah, let's see in this library, because you do need to make ident. Well, what do they prefer? New EQ name. If
is new var.
get unused username. There we go. Let's see. Okay, well, that's
Something in here.
okay. Let's see it. Only used there. Great. Okay. That's awesome. Where else? Where else?
So it's defined in the standard library.
I'm just not importing the right thing.
I don't know how, do we use STD? It's in STD lean meta. It should be in lean.name.
So you're saying std? Yeah, no, I have meta.
Oh no, it's using meta, but it's lean.name.
Okay. And let's get unused name.
Then it takes get unused username.
User.
Then it takes a context.
Yes.
A local context, yeah. But it doesn't like it's found. It doesn't look like it's found it.
Sorry.
It's still saying it's unknown identifier. So I don't know whether I don't know how I get from looking at this file to knowing what to import.
Yeah. But you found it in the lean.
Well, it's in a file called stud/lean/meta/unused names.lean, and which has a namespace declaration of lean.name.
Which repo?
Oh, sorry. I should put the link in there. Where's the best place to send you the link? Yeah.
Hey, malware guy, if you're still watching.
Oh, malware guy.
Yeah, we did some improv together. So.
Okay.
Yeah, he also has a Twitch stream for, well, doing more malware stuff. Thanks. Okay. This is perfect.
Well, then how do you know how to import that? So it looks like it should be in lean meta, but then it has this namespace declaration of lean.name on line 12.
Okay.
I don't know whether that means you import it from there or. Yeah, so it doesn't exist.
Here we go.
Oh, okay.
Oh, no, not lucky enough. No, just.
Yeah, so I don't know how you import it.
Okay, but we have the other place that used it. Or we did. Was here. You can see they import these things. Here's some things they open. It's
maybe you have to open it then.
Which
well
one?
as, we are opening it. Oh, but maybe you have to import it and then open it. I don't know.
Yeah, this looks good.
But then McIdent is probably ambiguous or something.
Which one did we miss? It opens tactic twice. Look at the tactic.
Well, that's the secret.
Yeah. Okay. I don't think it needs this.
We got lean twice in the list now.
Okay. So is it
Was
just
it parser?
It's what
I wouldn't have guessed that from, but now McIdent is complaining.
Yeah, this is a type error, I think. Undefined identity. Oh no, okay.
No, it's still it's in the wrong place.
Okay, it's just get unused
Username.
And then this name. New var name.
It does return a name.
Yeah, so maybe we don't need make identity.
But then you need to get, what were we doing before? We calling McIdent on a fresh ID, but that was a name or not a name?
I don't know yet. Still unknown identifier.
Yeah, okay.
But did I use the right capitalization? And saying here it is. Local context. Oh, it's a pure function, so no need to do this.
Mm-hmm.
Do this, but it's still an issue.
What's the angular bracket pipe thing that they use there in this repo where they apply it?
This is
there.
Yeah. So this is they're basically saying, okay, they're just adding this context as a parameter here in the middle.
Yeah.
Oh, okay.
It's just a weird way to call it. It's the reverse.
Yeah. Yeah.
Oh.
Yeah.
Interesting.
Yeah. I
Okay.
I use it a lot, but I haven't used it like this because this is the second parameter, right?
Yeah,
To this
it's very
function.
weird.
Yeah, I don't see how it would add any clarity to the code in this case.
It's like a reverse, but yeah, but this it's just like, yeah. In this case, I don't see the clarity either. Yeah, you're right. Yeah, yeah, I don't get it.
Okay, but so that's not the issue. I thought they defined it maybe somewhere else.
But we can just do this, like that's fine. Like,
Yes, I still think
yeah.
this doesn't exist. So I don't know how to use it.
It's
It's a pity.
Let's just see if they open anything else. I'm just gonna open all of these things again. Let's give it time. No, okay. Okay. It's not because I didn't open something. Now we can go to each one of these. That's so weird. Standard for, so this is the standard library.
Lean meta unused name. Lean meta.
Namespace lean.name. Okay. How about this? Lean dot. Any completion? Yeah.
Okay. What did it?
Oh. Unknown constant lean.name.
Okay, so it did some expansion of name to lean.name.
Oh, okay. Okay, what does this function
There we
do?
go. Well, it calls that get unused username index, and all it does, it loops through the whole thing and finds the minimal integer such that suggestion concat I is not in the context.
Okay, okay. Context dot. Ah. And this is local context, right? Yes. Okay.
Maybe std.lean.meta. Did you try that already? Dot unused names.
Say again.
Well, when I search for get unused username, I find the library std.lean.meta.unused names. Maybe it's in there.
std.lean.meta.
Unused names. No, dot unused names, and then std.lean.meta.unused names, and then dot get unused usernames. Unused names, both capitalized. Unused, yeah.
Like this.
Yeah, no, it doesn't work. Okay. never mind then.
Where did you see that?
Well, I was just searching for lean get unused username, and then here is there's a function. Yeah, they define get unused username.
See, also like here, I feel like they're exposing it.
So I found another file which uses it, which does a different import.
Yeah.
which I've posted in the Twitch channel.
Okay, cool.
I have no idea. This is bizarre. So they import this thing.
Okay. I'll do anything you want. Here we go. Wait.
Yeah, but the thing is that you can't type check because H is not a name. It takes two arguments, context and name, so that I don't know until it doesn't type check, then everything's broken now. Sorry.
Whoa. Yeah, let's see.
So I've posted here the repo where they define which I found where they define it.
Can you post in the Twitch chat or in the file?
I don't have either open.
Yeah, like
I can post it in the Twitch chat. I can forward it.
Okay.
Don't worry.
Okay, cool.
I can't.
Yeah.
Okay, let's see. Yeah. This is what I also.
Yeah. So this is found. Yeah, this is where we.
So this is great because you just need to pass a name, and you're just you're just in the monad because it does the get local context for you. It's this is the one we want to use. Like
that is the one that is the one in main. That's in the head of the repo.
Yeah.
Of the stood for repo. Okay.
This is interesting that like importing this breaks things for us. Like can't do intro anymore.
Well, the import it opens lean.meta. What? But if we import it, it shouldn't. I don't know what the semantics of import is. I can't remember.
Okay. So what if we just do it after? No, import has to be first.
Why would it break stuff? Because it opens lean.meta. We're already doing that.
Well, maybe. Well,
what's its problem? Why is it complaining? Unknown identifier get main target. You definitely have to open meta. Have to open something. But then why is that making? Oh, is it intro H prime?
What's the error? No goals to be solved.
Oh, is it maybe because it introduces more things to the simplify tactic?
Yeah, it's got a side effect of the import. Lovely.
Huh.
Simply just more powerful now.
Oh, for fuck's. Okay.
This is so annoying.
Okay, but that's
why though? I mean, I'm looking at it. It's still. Why is it leaking stuff? That's really bad.
Is at least the get unused username working now?
I think so. But it's not really working.
Yeah, but it needs a name, not an H, doesn't it?
Just Okay.
No, it doesn't.
Yeah. No. Now it's working.
Well, so what is this? Is this H? This string can
Yeah. Let's see.
auto computed to a name.
Let's see.
Oh, bro.
H1.
Yeah,
That's good.
yeah. That's good.
But
I guess the H was not there.
yeah, see, this is not right. Okay, we need to say at least. Okay, I think.
Oh, but the thing is that I guess we're calling get unused username, but then the context hasn't been updated or something.
Yes,
Because
exactly.
we want, yeah. So,
but this is fine. This is fine.
Yeah.
So we just have to pick unique strings from, like,
yes, locally unique.
Locally unique, and that we can deal with that. Like that's
Yeah. Well, we can deal with that one.
So I think we figured that out. This
That's really bad.
Yeah,
It's a way of saying like, do not pollute my namespace, please.
Yeah, but
I just want this single identifier.
We put it in a section or something.
We'll fix this by it'll be in a different file.
Excellent. Yes.
We just need to like fix our import here. And I want a better name for this tactic, but okay, if we go here, we can say dot tact, and then save, and we go like bold. There should be this says some errors which I know about. So if we do this, it should go away. Okay, that's okay. Now let's see if we can import. Yeah, and now this, but there was an error in that one proof. Let me just need to fix that. This was referring to Y, but introducing X. Oh, I just needed to introduce that. This can die. Okay. No. Okay, we need to fix that still. Oh, can we open this?
Open.
No. Import should be enough, right? And then these two should die. Yeah. Yay. Okay, cool. So that fixes it. Yeah, so that's metaprogramming and Lean. I think that's enough for today.
Fantastic.
Yeah.
Just in time.
Yeah.
Perfect.
Yeah, so
thank you, Walter. That was good.
Pattern matching, on our goal and our hypothesis, and how to apply our hypotheses with like interpolating the name. Oh, this is, oh yeah, we can now also do this. Yeah. Cool. So I'll stop the stream. Thanks everyone for watching. And I hope you learned something. I definitely did.
Yeah.
Cool. Let me just always forget how to stop. Every time.
Fix it in the edit.
Yeah. Fix it. There we go. Stop live stream. Okay, bye.